Okay, students, so today we will learn about integration area by integration. So there are three types of question. Area under the curve region bounded by the given function, vertical line, and the x-axis. The second one is area under a curve region bounded by the given function, horizontal lines, and the y-axis. The third one is area between curve defined by two given functions. The first point, area under a curve region bounded by the given function, vertical line, and the x-axis. So the given function, vertical line, this line, vertical line, and then bounded by the given x-axis. Okay, so area under the curve is this part, the shaded part. If fx is continuous and non-negative function of x on the closed interval a and b, then the area of the region bounded by the graph of f, the x-axis and the vertical lines x equal to a and x equal to b is given by this function. Let's try the first example. First example, find the area in the first quadrant bounded by fx equal to 4x minus x squared. So it is a quadratic equation and you will get a parabolic graph and the x-axis. So that means you have two boundaries, which is this point you have two boundaries means this point and this point. This point we call it as x-intercept. This one also x-intercept. So that we need to find what is the x-intercept of this function. So let's find what is the x-intercept of this function. X-intercept means when the fx is equal to 0. So you will have 4x minus pi x squared is equal to 0. Then we can factorize the x. So you will get two x-intercept, which is x equal to 0 and x is equal to 4. So this one must be 0, this one must be 4. So that the area is equal to integral of 0 bounded by the two x-axis, which is 0 and 4. So 0 until 4, 4x minus pi x squared dx. It means the integral of this function respect to x. So that you will have 4 per 2, because this is a 1, the power. So you have 4 per 2 times by x to the power of 2 minus by 1 per 3 x. The boundaries is 0 until 4. This one we call it as definite integral. So we can calculate like this. 2 times by, substitute the x become 4, 4 square, minus by 1 per 3 times by 0 cube, 4 cube, minus 2 times by 0 square, minus by 1 per 3 times 0 cube. Let's calculate this one first. So the answer is 32 per 3 square unit. Okay. So this one is the result for this question. Let's continue the next one. Example 2. Find the area bounded by the following curve, y equal to x squared minus 4, and the horizontal line, which is x equal to 4. So let's discuss for this one. So that means we need to find this point and this point. This point for sure is x equal to 4. And this point, we call it as the x-intercept of this parabolic function. So let's find the x-intercept. X-intercept means when y equal to 0. 0 equal to x squared minus 4, or 4 is equal to x squared, then x is equal to plus minus 2. Or we can say x equal to 2 or x equal to minus 2. So we're going to use the x equal to 2 because it is in the positive side. So we can find what is the area. Area is equal to integral 2 until 4 x squared minus 4 dx. So that you will have 1 per 3 x cubed minus 4x from 2 until 4. So we can calculate the definite integral for this one. Per 3, 4 cubed minus 4 times 4 minus by 1 per 3, 2 cubed minus 4 times by 2 is equal to, let's find the result. Let's calculate it. The result is 32 per 3 square units. Okay. Clear all drawing. Okay, let's continue with the next one. Okay, area under a curved region bounded by the given function, horizontal line, and the y-axis. So in a certain problem, it is easier to rewrite the function in terms of y and calculate the area using the horizontal element. In this case, the formula for the area will be dy dy, so respect to y from C until D. Let's do the first example, the example 1. Find the first quadrant area bounded by the following curves, y equal to x squared plus 2, and y equal to 4, and x equal to 0. So that means I need to find what is this. And for sure, this one is y equal to 4. Okay, and this one is the y-intercept of this function. So let's find the y-intercept. X squared plus 2 equal to y. Y-intercept means when x equal to 0. So y is equal to 2. So this one must be 2. So the area is equal to integral of 2 until 4 it must be gy dy. So we need to change this one first in terms of y. So you will have y equal to x squared plus 2, so that x squared is equal to plus minus square root of y minus 2, so that you will have, we can just directly x equal to plus minus y minus 2. So we can choose x is the positive side, y minus 2. So that the area will be okay. So area will be equal to integral 2 until 4 y minus 2 to the power of a half dy. So let's calculate it. 1 per 3 out of 2, y minus 2, 3 out of 2. It's from 2 until 4. So you will have 2 per 3, y minus 2, 3 per 2, 2, 4. So that we can calculate 2 per 3 times by 4 minus 2, 3 per 2, minus 2 per 3, 2 minus 2, 3 per 2. The answer will be 4 square root of 2 per 3 square unit. Okay, we can continue for the next question. Okay, next question. Area between curve defined by two given function. So it means there will be two functions in the graph. So you can find using a vertical element which is y2 minus by y1. It means function 2 minus by function 1. If you use the horizontal element, you can use x2 minus x1. Let's practice for this one. So find the area of the region enclosed by the following curves: y equal to x squared and y equal to x plus 6 and x equal to 0. Let's discuss this one. So y equal to x squared is the quadratic equation. Y equal to x plus 6 is this one. X equal to 0 is this one. X equal to 5 is this one. Okay, so it means we need to find this intersection point. Okay, so there will be two points. We need to find this intersection point first. Okay, and that's all. And this one is 0. Okay, so let's find the x-intercept first. The intersection point between y equal to x squared and y equal to x plus 6. So we can write down x squared equal to x plus 6. So you have x squared minus x minus 6 equal to 0. So that you have x minus 3, x plus 2 equal to 0, x equal to 3, or x equal to minus 2. So this one is x equal to 3. So that we can find the first area, this is area 1. I will mention this one is area 2. So area 1 is equal to, this one is upper, this one is the first function, this will be the second function. So actually, we're going to find the area of under this curve. If you want to find the shaded area only, so you need to minus by the area under the quadratic curve, which is this part. So we can write down as integral from 0 until 5, until 3 for this area. It means x plus 6 minus by x squared dx. While area 2 is equal to integral from 3 until 5. This is the first equation, x squared minus by x plus 6 dx. So we can solve one by one first. This will be a half x squared plus 6x minus by 1 per 3 x cubed from 0 until 3. So that means you have a half times by 3 squared plus 6 times 3 minus by 1 per 3 times 3 cubed minus a half times 0 plus 6 times 0 minus 1 per 3 times 0. Okay. I will leave it for you to calculate. And then for this one, it will be integral 3 until 5. You need to open this bracket first. X squared minus x minus 6 dx. So that you will have 1 per 3 x cubed minus 1 per 2 x squared minus 6x from 3 until 5. So that you will have 1 per 3 times by 5 cubed minus a half times by 5 cubed minus by 6 times by 5 minus 1 per 3 times by 3 cubed minus by a half times by 3 square. Sorry, this one must be square. Square minus by 6 times 3. So that you will have the area 2. Area is equal to area 1 plus area 2. Yeah. Okay, so this our discussion. We'll continue to the volume of revolution next week, next meeting. Thank you.